All right. So, your reminders on Thursday of next week is the last day for any late missing work retakes. Friday, you are going to have a quiz. You are going to have to balance 3 chemical equations, and you are going to have to identify all the different parts of a chemical equation. Here's the good news about the quiz, ladies and gentlemen. I'm going to count this as a bonus quiz, meaning I will give you a score on this, and then I will tell the computer to drop whatever is your lowest score on any quiz has been this trimester. So whatever your lowest quiz score was, it will go away. If you're missing a quiz, it will go away. Okay? So that is what I will do with that quiz on Friday. Okay? Today we're going to talk about 2 types of chemical reactions, synthesis and decomposition. We are going to actually write an entire balanced equation. From the words, we're going to make the formulas, then we're going to balance it. And then I'll give you some more time to work on the worksheet to do some problems like we're going to show you how to do today. So that is the plan. Questions? Here is the exam schedule, ladies and gentlemen, for the 26th and 27th. You guys will be the second exam, the final exam on the 27th from 9:15 till 10:45. Your exam in here will be a lab that we will be doing that day. We'll start it ahead of time. We'll do the actual lab that day. We'll do pre-lab ahead of time. We'll do the actual lab that day. You'll turn it in, and that will be the last thing that you will do for me until the second trimester. Questions? Okay. So with that in mind then, ladies and gentlemen, let's talk about the types of reactions. There are 4 basic types of reactions that we are going to deal with. We're going to deal with 2 of them right now. Now, these 2 types of reaction, ladies and gentlemen, are reactions that I will give you completely, meaning I will describe all of the reactants and all of the products for you. You will not have to predict anything. I have to give these to you. These are also the 2 easiest kind of reactions to identify, ladies and gentlemen. So when you're looking at chemical reactions, and we'll go back and look at some of the ones that we have been balancing over the last few days, these are the 2 easiest types to identify. So the first is what is called a synthesis reaction, ladies and gentlemen. A synthesis reaction is a reaction in which 2 or more reactants, now your reactants could be compounds or they could be elements, combine together to make only one product. There is only one thing that is created. A general formula would look something like this. A representing an element plus BC representing a compound would become a compound ABC. All 3 things put together into one. Now there is an example there. Diphosphorus pentaoxide plus water would produce phosphoric acid. These 2 compounds coming together would make this one new compound. This is balanced by putting the 3 there and the 2 there. The 3 here comes from the fact that PO4 has a -3 charge. Okay? This is a covalent compound, so that would be one that I would have to give you because I wouldn't expect you to know how to put phosphorus and oxygen together into a compound. I would give you the name like I just did. And then there is water as another reactant. Please remember, anything before the arrow is a reactant, anything after the arrow is a product. And you'll notice that there is no plus sign after the arrow. That is the easiest way to identify a synthesis reaction. There is no plus sign after the arrow in this equation. Because of that, there is only one product, and it has to be a synthesis reaction. Synthesis means to put things together. So this is the simplest, one of the two simplest kinds of chemical reactions. Questions, ladies and gentlemen? The second type of chemical reaction is the exact opposite of a synthesis. Synthesis means to put together. The next one, ladies and gentlemen, is what is called a decomposition. It is literally the exact opposite reaction. In this reaction, one reactant breaks apart into two or more products. The general formula for this one is the exact opposite of the last one. ABC breaks apart into A plus BC. And again, I'm just using that to represent elements and compounds. Maybe it breaks apart into two compounds, maybe it breaks apart into two elements. But one thing breaks up into two or more things. Our example, two lead-4 oxides will break apart into two lead-2 oxides and diatomic oxygen, or an oxygen molecule. Now, just like we identified a synthesis by there's only one thing after the arrow, in a synthesis, or in a decomposition, there is no plus sign before the arrow. So when you're looking at your chemical equation, if there's no plus sign before the arrow, that has to be a decomposition reaction. Take your packet. Next to the number 1, 2, 3, 4, 5, 6, 7, 8, all the way to 20. Find any synthesis reactions and please write an S next to the number for the problem it is. If it is a decomposition, please write a D by it. I'll give you 3 minutes to find them, ladies and gentlemen. So look over all 20 of these reactions. Now, they're not all going to be synthesis or decomposition. But please find me the ones that you think are synthesis or the ones that you think are decomposition by the information that I've given you and the rules that we have set. All right, who's found a synthesis or a decomposition reaction? Number 9 is a synthesis. Well, let's take a look. Number 9 is in fact a synthesis. Easiest way to tell, here's the arrow. Afterwards, there is no plus sign. There is only one product after the arrow. Number 9 is a synthesis reaction. Jade. "17 is a decomposition. Here's your arrow. There is no plus sign before it. This one reactant is breaking up into these 3 different products. That is the definition of a decomposition reaction. One thing breaking apart into others. Any others? "15 also happens to be a decomposition. Here's the arrow, no plus sign before it. One thing breaking apart into 2 or more. In this case, 2. Any others? That's it. Now, we'll talk about another type of reaction tomorrow. We'll talk about another type on Friday. And there are some that are on this sheet that are just not going to be any of those 4. There are more than 4 types of reactions in the world. Okay? But you have identified all of the synthesis, all of the decomposition. Anyone have any questions on that? Okay. Then what I'd like you to do, ladies and gentlemen, is turn your packet to the page that has problem number 20 on the top. And we're going to work on the problem right below that. Okay? We're going to work on the problem right below number 20, ladies and gentlemen. So, for us to do that, ladies and gentlemen, here we go. An aqueous solution of aluminum nitrate reacts with an aqueous solution of sodium hydroxide to form a precipitate of aluminum hydroxide and some sodium nitrate dissolved in water. So, that is giving you all of your reactants and all of your products for this particular reaction. Now, it doesn't matter which reactant you list first on the reactant side. It doesn't matter which product you list first on the product side. That doesn't matter at all. You can flip-flop those around, okay? But what is on the reactant side should be before the arrow, and what is on the product side should be after. So again, an aqueous solution of aluminum nitrate reacts with an aqueous solution of sodium hydroxide to form a precipitate of aluminum hydroxide and some sodium nitrate dissolved in water. So, let's begin with the very first thing we're given. An aqueous solution of aluminum nitrate. That is the first thing that we are given, an aqueous solution of aluminum nitrate. Now, from that, ladies and gentlemen, we need to write a formula. So, I need someone to tell me what the formula of aluminum nitrate is. In other words, just like in the last unit where I asked you to write the formula for the name aluminum nitrate, what would you have written? I'm sorry, what was that? Okay. Can I ask why you put the NO3 in parentheses with the 3?
Because you can't combine the 3 that you bring over from aluminum. So aluminum's a plus 3.
Okay. So if you remember, ladies and gentlemen, for aluminum nitrate, aluminum is a plus 3. Nitrate, NO3, is a minus 1. We need to create a compound that has a total charge of 0. We still do the crisscross method. So this compound that Caden just gave us, I'm going to put right here. That is our first compound. Okay? Now, aqueous means that it is dissolved in water. How do we distinguish aqueous in a compound? Give you a hint. All acids are aqueous. We put an AQ after it. Mr. Brand. Nope. Okay. Thank you. Bye. All right. So that is our first reactant, ladies and gentlemen. Okay? That is our first reactant. Now it says it reacts with aqueous sodium hydroxide. So aqueous sodium hydroxide is our next reactant, ladies and gentlemen. Okay, we know what aqueous means. It means we're going to put an AQ after it. So how do I write sodium hydroxide, ladies and gentlemen? How do I write a formula for sodium hydroxide? Nora, what do I do? Na first.
And then OH. Or wait, no. Yeah. OH2. And then OH.
Okay, let's slow down. You got the Na, you got the OH. What charge does Na have?
Oh, 1.
Plus 1. What charge does hydroxide have? Okay, so now when we do our crisscross method, we take our charges from up above and bring them down. What would our final formula look like? Good. You don't have to do this all at once. You don't have to do this in your head, ladies and gentlemen. You can do what I am doing. On the side, Na plus 1, OH minus 1. Combine the two. Now I get NaOH. Now no parentheses here because I didn't need to put a number by the OH group. But I am going to put AQ. Okay? I am going to put AQ. All right. Now, to form. Form is an important word here because it means now I'm shifting over to the other side of the equation. Now I'm shifting over to what is after the arrow. Okay? To form a precipitate of aluminum hydroxide. Aluminum hydroxide, ladies and gentlemen. Okay, I need to write a formula now for aluminum hydroxide. What's my formula for aluminum hydroxide going to look like here? Jalen, help me out. Al. Okay, so now when I do the combination of these two to get my charges to 0, what does it look like? Like that? You're close. Yeah, I need to put the OH in the parentheses. Okay, I need to put the OH in the parentheses. If I'm going to take this 3 here and put it down by this OH, it has to go in parentheses. Okay? Now, anybody remember what a precipitate means? Precipitate was one of the 4 signs of a chemical change. A gas released, a change in energy, a unexpected color change, and a precipitate forming were the 4 signs of a chemical change. Anybody remember what a precipitate actually was, though, the definition of it? A precipitate is a solid that settles out of solution. So therefore, ladies and gentlemen, for the state, we are going to put S. Because a precipitate, by definition, is a solid that will settle out of solution. Okay? So we put the S by it. All right. Last part of our equation here, ladies and gentlemen. And some sodium nitrate dissolved in water. By the way, what's another way of saying dissolved in water? Aqueous. We could do it either way. Either way. Okay. So now I need to write a formula for sodium nitrate. All right. What's my formula, Stephanie, going to look like for sodium nitrate? I'm sorry, what was that? No. Plus 1. Thank you. Okay, good. Nitrate. NO3 negative 1. So when we're all done, what does it look like? What should I write in this box? Well, am I going to put a number by the NO3? I know, but are you going to put a number by it? Then don't put it in parentheses. Okay? The only time I did not put the OH in parentheses here, because I was not putting a number by it. I put the OH in parentheses here because I was putting a 3 by it. Here I put the NH3 in parentheses because I was going to put a 3 by it. What number goes by the NO3 here? The 1 would come down for it. So I'm not going to bother to put it in parentheses, okay? So that's the difference. And dissolved in water, AQ. AQ. Okay? Now this is not one of the 4 types of chemical reactions we have talked about. This one we probably won't get to until Friday. But I do want to point out a couple of things. You have 2 aqueous substances forming a precipitate and another aqueous substance. I'll give you a little bit of a preview. This is called a double replacement reaction. This is called a double replacement reaction. We have 2 compounds forming 2 new compounds. But what actually happened in these compounds to make these things? The what did?
The polyatomics swap.
The metal switch places. Exactly. The aluminum metal switched what it was with the sodium. Sodium is now with the NO3. Aluminum is now with the OH. That is a double replacement reaction, ladies and gentlemen. 2 things are going to switch places with each other. You're going to create 2 new compounds. Okay? This is the key to this reaction. We find what is called a precipitate. There are a few things that will tell you a double replacement reaction has occurred. Because remember, you can mix 2 things together and nothing can happen. There can be no reaction. You remember when we put certain acids with certain metals and things and nothing happened? That's absolutely fine. But if a reaction is going to happen, these 2 metals are going to switch places, and one of these 2 things needs to be a precipitate. We're going to show you how to find a precipitate by the end of the week or Monday at the latest. But we now have an equation that all we need to do is balance it, just like we have done for the last 2 days. So again, here's my scoreboard, okay? All right, what are the elements that are involved? Well, we're involving aluminum, Al. We are involving nitrogen, N. We are using oxygen, O. We are using Na, and we are using hydrogen. Now, any diatomics here? Any diatomics? No. So we're not even thinking one half trick here. Not even entering your mind. Not even a possibility. What trick should we be thinking about though? What little trick or tip should we be thinking about? What? Ignoring oxygen. Oxygen is in every one of these compounds. I'm going to ignore it for now. Why am I going to ignore it? Because every time I put a coefficient in here, it's going to change. And I don't want to confuse myself along the way, so I'm just going to ignore oxygen for now. Just going to forget about it. All right, so now, just creating a little space for myself here to continue writing. All right, how many aluminum on the reactant side here? Kaela? 1. How many on the product side? 1. Thank you. How many nitrogen on the reactant side here, Anna? I'm sorry? 3. Yep, absolutely. How many on the product side?
3.
Nope.
Oh, 1, sorry.
Yep, be careful. No number by it means there's only 1. The reason for the 3 here was the parentheses. The parentheses allowed this 3 to distribute out to both the nitrogen and the oxygen. I'm ignoring oxygen. Just the easiest thing for me to do right now is ignore oxygen. Okay, next is sodium. All right, Claire, how many sodium on the reactant side?
1.
How many on the product side? Okay, good. How many hydrogen on the reactant side here, Alan?
1.
How many on the product side?
3.
Okay, so we've got a couple of things that we need to balance. We've got nitrogen and we've got hydrogen. That's it. Which one would you like to start with, Linda? Hydrogen? Okay. So, the side that needs more hydrogen is the reactant or the product? Which one? Okay, so here's hydrogen on the reactant side. So what number times one of them will give me the 3 that I am looking for, Linda? So I'm going to put a 3 in front here. Sorry. So let's put a 3 in front there. All right, now I need to update everything in the bottom that I just changed. So what did I change here, Lily? Putting this 3 in front, what does that change down here? Okay, how many sodium?
3.
And how many hydrogen?
3.
Good. Again, we're not worried about the oxygen. We're fine. We're not worried about the oxygen. Okay, so now I've got to balance either the nitrogen or the sodium. Safira, which one do you want to do? Okay, so which side needs more? Okay, here's nitrogen on the product side. What number times 1 is going to give me the 3 that I need? Going to put a 3 in front. Okay, so now instead of 1 nitrogen, Safira, how many? 3. What else changed though as well? How many? Okay, if we have done this properly, ladies and gentlemen, the oxygen should now be balanced. So, how many oxygens are there in this first compound right here? How many oxygens? What? 9. How many oxygens in this second compound right here? And remember to account for the 3 out in front. 3. Total on the reactant side, 12. Now we come over to the product side. How many oxygens here? In this one? 3. And how many over here? for a total of, there you go, ladies and gentlemen. There you go. Questions? Now, I will tell you this. If you do not get these charges correct, you may end up with an equation that you cannot balance. If you do not have this as a plus 3 and this as a minus 1 and have that 3 there and have this as a plus 3 and a minus 1 and have this 3 here, you will never get it to balance. If you were to make this a 2, you will never get this to balance. It won't do it. So if you are working on a problem and you're like, man, I cannot get this to balance. I cannot get this to balance. I can't get the right number of these on one side. When I change it, it then messes everything up. Go back and double check your formulas. If you wrote a wrong formula, it'll probably mean you will never get it to balance. Okay? If you have good formulas, it will work out every single time. Questions? Okay. So let's take a look at one more, ladies and gentlemen, and then we'll give you some time to work on these. We're going to do the one right underneath it. Now, the one right underneath it, ladies and gentlemen, is one that I would have to give you all of this information. Because looking at the setup of this, what kind of reaction is this? Because there's only one thing before the arrow, right? So a decomposition reaction, I will never require you to be able to know the reactants and the products of. I will have to give them to you. Okay? So, let's take a look. Sulfur trioxide gas decomposes into sulfur dioxide gas and oxygen gas. Okay? So that is the reaction that we are doing here. Okay? So, sulfur trioxide gas decomposes into sulfur dioxide gas and oxygen gas. Again, the important word in this entire sentence, there are many of them, but the one that everything pivots on is right here, decomposes. Because this is separating the reactants from the products. One reactant, two products. Okay? So, sulfur trioxide. What is the formula for sulfur trioxide, Ethan? The formula for sulfur trioxide, please, Ethan. Okay, are you sure on that? Okay, did we have to do anything with charges? No, this is a binary covalent compound. There are no charges here, no minuses, no pluses. You have two nonmetals together. You are writing it down entirely based on the name that you are given, and sulfur trioxide is SO3. Now, what state of matter is it? So let's put a G after it. Okay? As much information as you can get, we're going to add it to our balanced equation. Decomposes into sulfur dioxide gas. Sulfur dioxide gas. Crystal, what is the formula for sulfur dioxide gas? Perfect. SO2. Again, another covalent compound. Another one where you don't have to worry about the charges because you would have two negatives anyway, so they cannot possibly equal out to 0. So we write down what we're given in the name. Sulfur, 1, di, 2, oxide, oxygen. SO2. What state of matter, ladies and gentlemen? Gas. And oxygen gas. What is the formula for oxygen gas? What is the formula for oxygen gas, Ariana? Thank you. And you did something very important here. You don't put this 2 here. This is wrong. By the way, why is there a 2 here? This is one of the 7 diatomics. This is one of the 7 that when it is written alone, you need to put a 2 by it. Divine. Thank you. Okay? So, we would never write just O. It's always O2 when it's alone. Here, it's with something. I write it based on the name. Here, it's with something. I write it based on the name. Here, it's alone. It's O2. Okay? What state of matter is it? It's a gas as well. All right. So now, ladies and gentlemen, now we are going to list what we have. S and O. That's it. Just the 2 of them. How many sulfur on the reactant side? How many sulfur on the reactant side, Jasmine? Okay. How many on the product side, Jasmine? 1. Okay. How many oxygens on the reactant side here, Yasmin? 3. How many oxygens on the product side here, Yasmin? How many? 4. 2 oxygens here. 2 oxygens here. Total of 4. Okay. Now, there are 2 ways to balance this. Okay? I am going to choose to do the easier way. Anybody know what the easier way, by putting 1 number in, I can get this to balance? And it's a weird little trick that you can do with this. How can I get this to balance putting 1 coefficient in? What's the only thing I can put a coefficient in and only change 1 thing? What coefficient can I put in front of there to balance this right away? Because actually, I need what for oxygen on this side compared to this? How can I make less oxygen over here? What? I'm going to put 0.5 there. I'm going to put 0.5 in front of the O2. Because now instead of 2 oxygens, there is what? There's 1 here now. How many total on this side? Is that balanced? See what? Oh, okay. Can I leave it this way, though? So what do I do to now take something that is balanced and make it proper? Double. So what goes here in front of the SO3? What goes in front of the SO2? And what happens to the 1/2? Becomes a 1. So I don't need to write anything there. Everything stays balanced. This does now become 2. This does now become 6. This over here becomes 2. Here you've got 4. And now you're back to 2 oxygens over here. There's your 6. Questions? 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 you have got 4 more problems just like that you can do on this worksheet. If you haven't finished the first 20, keep working on those. If you have questions, you raise your hand, you call me over. I will be more than happy to come over and assist you. Otherwise, ladies and gentlemen, that's what I got for you today. You've got basically 30 minutes to practice, 30 minutes to get some things done, 30 minutes to figure out if you know what you're doing. Your phone, no. Thank you. If you're going to write an equation like we did on the board, you'd like me to come over and look at it before you try to balance it, I would be happy to. If you're sure of your formulas and you want to go right on the balancing, you are welcome to do that as well.
Yeah, exactly, so it's like, we're doing that, so it doesn't really matter. I just have to tell.
Oh my gosh, I wrote one about something. And I turned in high school. I was literally so. What?
Yeah, you.
It's a good idea, like, yes,
Larry?
yes, but I also like present.
No, that's separate. You're big capital letters, separate else. And you multiply by the P as well. So instead of one P, there are two. Instead of 4 holes, there are 8. Okay, and then 2 outside distribution, everything inside.
Oh, wait.
Question or?
Oh, God.
Okay. Carbon monoxide. Carbon monoxide.
Yeah.
When you say carbon dioxide, it would be CO2.
What the hell? I don't understand. Wait. I don't think I did it. 1.5. So each times it
Yep. Yep.
Wait, what if you did like?
Absolutely.
Oh, I hate this. I'm gonna try to. I know how to. But I didn't. Yeah. I'll be ready. Okay, so I'm ready. Oh wait, no. Wait, yeah. Right when it's the outside, it just goes into the front.
It goes into both the bottom that are inside the front.
In the front. If it's in the front, it goes into the front.
The front it goes to everything else. Yep. Yep. Perfect.
Then.
The only thing I gotta wrap it on. I know. Stephanie, what can I do? What? Yes. Yes.
No, you're. Okay.
Going back to your original. One here.
And then.
One here. Two oxygens here. And then 4 oxygens. So, we need to get the oxygens evened out. Putting the 2 here and the 2 here. That's 5 oxygens. So we still need more over here.
Yeah, this only works on a page. You should be worried about it, the ending. That one doesn't
That's my one. Sorry. You're right.
No, I think. Or did we not move that? Why is that? But it was on
Okay. First of all, that one you started out with the 3 here, right? Okay. So, no, but you didn't update your hydrogens. So let's update your hydrogens first. Now, not on that side. So that's why I do everything under that arrow, so I keep sweet track side to side.
Wait, I'm so I think I agree. It's just no.
There were 2. The 3 in front multiplies everything by 3. Ah, but you forgot. Remember why we wrote this up here? You did. Well, let's not worry about the others. That's that one here. Now, excuse me.
Changes the oxygen too. Is it on point?
Remember that? There's no number by the sea. We were outside of the front. That would be different. There's only one. So Now, let's balance out the phosphorus. Okay, let's try that next. Do what you do to get that balance, and then see if that makes it a little bit easier. Okay, recount everybody. Okay.
Wait, then I think it's basically just taking a test and I come here.
Well, here's the what you did is.
Okay.
Let's see. Here this is.
Like not understanding. Yeah, like I'm not understanding how that's all true.
So I understand that you're trying to make this yourself, but just be careful.
Please, I need them to cancel
However you want to do it.
Please cancel out this place,
Under
please.
here.
I need them to, I need to just get out here.
Push 3 in front. 3, 6, and 6. Because the 3 just tripped.
Get out when it's still
Okay.
snow.
And then you do that same way over there. You now have 6 items.
Outside, I can't even see the snow, but like,
6 and 6s.
I just want to see the weather.
What about the occipital part? It's down to this comes down. It's down 20. So what's up over here? 6.
Oh. What about the floor?
So here, you've got 6 items. How many items is this?
I feel like
As long as you. One in front. All this. That's why you're missing the picture. So rewrite that one, and then that's why you're not getting it to them, which is a good lesson to learn. But because you wrote that one formula wrong, that was never going to matter. Okay. Aqueous means dissolved in water. In this case, I didn't tell you. In this case, I didn't tell you. I did. It's a problem. Normally, in the problem, aqueous buried in the ground. But I would tell you. Okay? I would tell you. But I'll also show you later on how we know the type of reaction.
After you.
That is not phosphoric acid. That is hydrophosphoric acid. Phosphoric comes from the phosphate on the back.
Oh, okay.